Good evening, everybody, and welcome to the Science and Engineering Virtual Open Evening at NUI Galway. My name is Gavin Collins. I'm one of the Vice Deans at the College of Science and Engineering at NUI Galway, where my role is focused on student recruitment. I'm also a microbiologist, so that might come in handy for some questions later on as well. We're going to have two separate parts to this evening. The first hour dedicated to science and the second to engineering. I'm hoping that my screen is going to share successfully. I've just been trying it and some colleagues haven't seen it. So I would appreciate if somebody might let me know if you can see my screen right now. And with that, whether you can see my slides. So I'll ask all of my panelists to please keep their cameras on for the duration of the recording. But for everybody else, I'll ask you to please turn your cameras off. You're automatically muted. And for the moment, I'll ask my panelists to stay muted as well. So we'll, as I say, split the evening into two parts then, into science and engineering. So I'll first of all give you an overview of the degree courses that we offer in science at NUI Galway, and we'll then have a panel discussion around science with some of my colleagues and with some special guests. I'll introduce those later on. And we'll have some time for your science questions. You can type your questions into the chat function throughout the evening, but perhaps particularly towards the end of the panel discussion, we'll be able to get directly to answering some of those. We'll hear from sport and about sports scholarships at about 7:50 until 8 this evening. And that's just before then we start the second half, where we focus on engineering and computer science. So we'll do it all over again for engineering, and we'll have an overview with some slides on our engineering degrees and how you might study computer science at the university. We'll then have a panel discussion, and we have again some guests, and I have some colleagues on that panel who'll be able to speak to some of the questions I think you might have, and we'll leave some time to answer your questions after that. So throughout the evening, we'll also have colleagues who can answer questions about accommodation, about mature students. So if you're thinking about coming back to university and you want to ask a question about your prospective role as a mature student, please go ahead and we'll be able to answer those. And equally throughout the evening, we can answer questions about sport. Okay. So without further ado then, I'm going to give an overview on some of the science degrees and the ways in which you might think about studying science at NUI Galway. So as I said, my role is as a Vice Dean in the College of Science and Engineering, but I'm also a microbiologist. So I can speak about some of the problems we have and why we think it's a good idea to be a scientist. Why, for example, I was motivated to do science, and why I think it's a good idea for you to consider science amongst your options. Let me just say briefly, first of all, about the university. We feel that we punch quite strongly and high globally. We're amongst the top 1% of the universities in the world as measured by the QS World Rankings. So this means that on lots of different measurements that we really do play with the best universities in the world. So it is a good place for you to think about pursuing your education. We have over 110,000 former students worldwide, so a huge network that you might want to connect to. We've been embarking on a huge building program over the last few decades, and particularly over the last decade or so, over 400 million euros has been spent on lots of new buildings and facilities that you can enjoy and benefit from as a student. Lots of our colleagues are amongst the most highly cited in the world, so they're at the front of their game and recognized internationally as such, and that bleeds into your learning. Over 98% of our graduates get relevant employment within 6 months of graduating, so we've got an extremely high employability track record. And our budget is something around 270, 280 million euros a year. So you can see the size or the scale of the university. But you might want to be a scientist. So that's what we're here to talk about in the first half of this evening. And I think, we can go on this journey and think about why you might want to be a scientist, how you can do it, and why NUI Galway might be a good place to do so. Well, perhaps the first question we should ask is, who are scientists anyway? And I think it's quite obvious that she is, he is, but I'm often asked, well, can I have a career in science even though I don't really want to work in a lab? And I would say yes. She's a scientist, Joanna Donnelly, who works with Meta Aaron. They're scientists, they're not in a lab. She's a scientist, perhaps not even working on this planet some of the time. He's a scientist, they're scientists. He's a scientist at the bottom of the ocean. She's a scientist in the energy sector. They're scientists as forensic scientists. She's a scientist as a communicator. So you can see that it's not just those people at the top. It's all of those others in the little clips that I've shown you. So scientists are required everywhere. And careers in science really, I would say, are as varied as they are many. And what makes each of those people a scientist is the core skills in which they've trained when they were a science student. And I think that's something that's really important that I suggest you try to see, that what unifies scientists all over the world is their core skills. And I've tried to think about, listing those skills, and my attempt at it is this, that the first one is in understanding big existential challenges and asking the right questions in an informed way. The second is in applying analytical tools and generating data to try to answer those questions. So those might be big questions like, say, around climate change or antibiotic resistance, or how we move to a cashless society, or how we think about how we move our cars without burning fossil fuels. But once you have the data that try to answer those questions, the next task is in analyzing those data. You'll then try to draw conclusions based on those results, and those conclusions will allow you to make some decisions. And quite often you'll find yourself as a scientist in a rather privileged position of being able to advise decision makers or make decisions yourself based on those results and on those data. So maybe you find yourself in a team of people in your workplace, and you're the only scientist, and everybody else is either in law or business or the humanities or languages or in some other skill area. And you as the scientist can indicate what may be the best course of action based on the results that you've perhaps generated, or because you generally just understand some of these questions because you're a scientist. The last of these skills is something that we really prize at the university, and that is in training our students to be really good communicators. And in science, it's really not just about communicating with your peers, although you've got to do that, but it's also being able to tell your non-scientist next door neighbor what you're doing and why science matters and what's going on with the pandemic, for example. And at the same time, being able to talk to a Nobel Prize winning scientist about your work. So I think it's about being adaptable and respectful, not talking down or being afraid to talk up to anybody. And that is one of the really important core skills as well of being a scientist. So why science then? Well, why should you study science and maybe try to earn a B.Sc degree? Well, it's to get those core skills, I would say. So if you have an inquiring mind and you'd like to develop those key skills and access the diversity of different fascinating careers, then a Bachelor of Science may be for you. The question then is, why Galway? Because you know, I would say that studying for your science degree in any of the top 1% universities in the world is a good idea. And frankly, it may not matter whether you get your degree from Harvard or somewhere in the UK or Europe or elsewhere in the US or somewhere in Ireland, so long as it's an excellent university. However, we think we do it exceptionally well at NUI Galway. And I've tried to boil down to the top 5 reasons why NUI Galway is a good choice for your B.Sc degree. And those are, well, firstly, that we have some unique specialisms. So some of our degrees are unique in the country, like, for example, our marine science degree. The second is around careers. So you heard me say already that we've got excellent employment prospects for our students who graduate from NUI Galway. And you can see, for example, in this table, the middle column here represents undergrad students, so those who have just graduated from their primary degree. And you see that nearly 55% are working full-time, another 36% are in full-time further study, and only 2.1% are still looking for relevant work. So most end up in relevant employment or further study. The third of these reasons is around our most influential scientists. So some of my colleagues in science and engineering are technically categorized amongst the most highly cited in the world. So it means that most other scientists are reading their work, and they become very influential. And this means that their passion gets a chance to bleed into their teaching then, and you can soak that up as a science student at NUI Galway. The fourth is around placements and fieldwork and study abroad. So all of our students get a chance to study abroad if they want, and if their grades are good enough and if they impress us sufficiently well in an interview that we'd have with them, then it's possible to study abroad for a whole semester or a whole term, usually during third year, and to take subjects in one of our partner universities similar to the subjects you would be taking had you stayed in Galway, and we'll then map the results back onto your degree at Galway. So it's possible to study in one of the universities of the University of California system, or John Carroll University in Ohio, or the Hong Kong University of Science and Technology. Equally, think about where we are in terms of fieldwork. We're located bang in the middle between the Burren beneath us, Connemara above us, the Atlantic Ocean to the left, and the River Shannon to the right. We're literally in a unique place in the world, and all of our students studying degrees such as marine science, earth and ocean science, some aspects of atmospheric physics, botany and plant science, zoology, and so on, have literally outdoor laboratories in which to do their science. And that is one of the huge benefits of being where we are. For placements, some of our students have, as a formal part of their course, the chance then to do a placement with an employer. And we'll hear a little bit about that from our panel in a few minutes. The last point here is around teaching infrastructure. So our students get to use our best equipped labs. We don't hide away our best equipment from our students, and each one of our final year undergraduate students gets a chance to do a final year research project in one of our labs. Okay, so lastly, let's think about how you can do this. So you can earn one of 31 different B.Sc degrees with us at NUI Galway. And that might surprise you because we actually list only 13 on the CAO. And I'll tell you why. Let's try to break that down to see what we offer. So we offer degrees across all of these different areas: environmental health and safety, physics, maths, chemistry, ecological sciences, various other lab sciences, and pre-medical sciences. So what I've tried to do is, I guess, put this in a way that's easy to understand. And I've made this, I guess, what looks like a tube map, right? And you can see that in our flagship degree, GY 301, the degree that some people call general science, we've got 19 different pathways. We've got maths pathways in yellow, we've got physics, and as I go clockwise around this map, we have medicinal chemistry and chemistry, earth and ocean science. In the pink, we have anatomy, pharmacology, and physiology. In the orange, biochemistry, plant and agri-biosciences, and in the green then, botany, microbiology, and zoology. So taking GY 301, it's possible then to graduate with a degree in one of those pathways. So we can talk about that also on the panel a little bit later on. It's also possible to take one of our 12 other degrees. So in those degrees, let me just blank out the 19 pathways there, and you're left with these 12 other degrees. So there's 2 in maths, as you can see, there's 1 in physics. And again, as we work clockwise around the screen here, you'll see there's 1 in biopharmaceutical chemistry, marine science, environmental health and safety, biomedical science, and then 2 new ones, genetics and genomics, and agricultural science. And then lastly there you can see biotechnology. So collectively, that makes the 31 different degrees in which you can graduate from. Lastly, let me just touch on one highlight, and that is for 2021, we're introducing agricultural science, a new B.Sc in agricultural science. This is where agricultural science makes a comeback to NUI Galway. There was a B Agri Science until 1979, and not now until 2021 will we have had a similar degree. So this is a program that is being taught by our college, but also by the College of Arts and Social Sciences. And we have one of the lecturers who will be working on that with us, and he'll be on my panel in a few minutes as well. But let me just give you an outline. Over the course of 4 years, you'll develop various different skills in agricultural science, but this will be mixed with biology, with chemistry, but also some social sciences and business and so on, so that you get a rounded education around the bioeconomy and agricultural science. And Peter McKeown will be able to talk to us about that in a few moments. There will be internships, study abroad options, and placements for projects, predominantly with partners like Teagasc. And lastly then, I guess I would say that this does speak to some really timely issues in the new century around sustainability, around developing the bioeconomy, and achieving some of the sustainable development goals of the United Nations. So particularly for an economy like we have in the west of Ireland, we think that this is going to be a really exciting degree for you to consider in 2021. So back to this question then, you want to be a scientist. Well, I would say you'll have those prized core skills that I've mentioned if you consider one of our options here at the university. And those core skills are going to be recognized the world over for a variety of positions. So rather than necessarily thinking about narrowing your options and where you think your career might take you, think about how your skills can be a calling card. And really it'll just be that your specialization in science then will then steer you towards perhaps a specific area and a specific career. The employment prospects include jobs in industry, everything from pharmaceutical through to computing and financial services and IT, in education at all levels, in research at all levels and privately and publicly, and in different agencies and semi-state companies and local authorities in places like Cuilche and Teagasc and EPA and so on. So there really is always a demand, and there undoubtedly will be an increasing demand into this century for scientists and scientifically literate people. So we don't know yet what will be the hot jobs in 2024 or 2025, but your core skills in science and in engineering indeed will be your calling card. Okay, so I'm going to stop talking so much at this point, and we're going to move on with the rest of the evening. So you can see the agenda here that we just had an overview of science at the university, and we'll proceed now to a panel discussion. I'll introduce my panel members, and we'll be able to take some of your questions. We'll then move on afterwards with sport and into the engineering part of the evening. So without further ado, this will be your panel for the science discussion. So I'm going to ask my fellow panelists to please keep their cameras on, and if they haven't already, to put them on, please. And let me just introduce you on this list before we go to them, and you can see my face again then. So we have Peter McKeown. Peter is a colleague who works in plant and agri-sciences at the university and can talk to us about the agricultural science degree that's coming up. Elaine Dunleavy is involved in our relatively new B.Sc in genetics and genomics, and I think also knows plenty about the biomedical science degree we have and about biochemistry. Marie Coggins is a colleague in physics, but is the program director of the B.Sc in environmental health and safety. Niall Colgan is the director of our physics degree, and Aisling McCluskey is with us from maths and can help us to think about that. We have two special guests on our science panel, and those are Marion Finnerty from Merit Medical and Brendan Toohey, who's the chief physicist at Galway University Hospitals. And last but not least, then we have three students with us: Shauna, who's a physics student, and Aisha and Keen, who are two of my students in microbiology. So we'll be able to put a question to them then. Okay, so I'll stop sharing my screen then, and I'll just move back to camera mode. And I'm hoping then that my panel is ready and maybe willing to take a few questions then. So what I might do then is start off with Peter, because you're first on my list. You can hear me okay, Peter?
I certainly can. Thank you. Thank you, Gavin. Can you hear me okay?
Excellent. So Peter, what I wanted to ask you then was whether you could tell us a little bit about the new B.Sc in agricultural science. And anything I've left out do you think people should know?
Yeah, I guess one thing that we do bring in is the importance of sustainability as part of the university's strategy in terms of sustainability of the environment. And as you mentioned, also the economic side of things. We partnered with the College of Arts and Social Science, so there's training in things like running your farming business as well. So the economic sustainability is there as well. That's backed up with firm foundation in the genetics, the breeding, and the agronomy, which also actually Elaine coming after me, we actually teach some modules into the more applied genetic side of things as well. So there is some sort of synergies between these different programs. The other thing to emphasize is that a few years ago, we signed an alliance on low carbon agriculture with Teagasc, who are heavily involved in this new program. There are opportunities for final year projects with Teagasc, especially with Teagasc Ath and Rye in County Galway, as well as on-farm training. There's also a third year work placement in an agri-business or agri-food business.
Sure. And I've two questions then for you, Peter. One, will prospective students need to have studied agricultural science for their Leaving Cert? No,
they won't. It's helpful, of course, but no, that's not a requirement.
Sure. And could I ask, how many students do you think you might have approximately in the first year of the course, so people get an idea?
It's a new program, but we're aiming for quite a small cohesive group, maybe 20-25.
Okay, so that would be a really nice small learning environment, I guess, then for those people, right?
Yeah, with some dedicated modules for the group themselves, as well as other activities from across the range of the modules offered.
Okay, excellent. So thanks for the minute. I'm going to move on to Elaine right now. Hi, Elaine. How are you? Oh, you're muted, Elaine. It happens to all of us, doesn't it?
Hi, Gavin. I'm good. Thanks.
Excellent. So Elaine, I'm going to try to get some value out of you now, because you're in biochemistry, but you know a little bit about, I think, the biomedical science degree, which is a hugely popular degree that we offer. And you're also co-directing the new degree in genetics and genomics. So what would you say to a student who's maybe considering any one of all three of those?
There are some similarities, I guess, between all those three courses, but there are also some differences. So I would say to get the prospectus out and look at the different subject choices that you have in each of these years. Of course, biochemistry you will enter through the, as you call, the general science degree. So maybe it gives you a bit more flexibility in the earlier years, and then eventually you will specialize in biochemistry, and that will be your path. But for genetics and genomics and biomedical science degree, they're what we call the denominated degrees. So in those cases, your subject choices are pre-chosen in advance. So it's whether or not you want to have a bit of flexibility, and maybe change your have some choice along the way, or whether you're more, really decided that genomics and genetics is for me and this is the path I want to go on. So sure. That's what I would say if you're trying to decide between those.
And I remember, going to lots of events, and students always asked whether we had a degree in genetics. So it really was, I think, something that we were waiting to do for a long time, and you launched it last year. Yes. But what kind of, say, student, or what kind of interests do you think a student might have if they're considering that degree? Because it's not just genetics, right? There's an informatics and genomics aspect as well. Isn't that correct?
Yes. So there's actually quite a considerable maths and computing component to this degree, and that's what makes it unique as well. So you have the combination of biology and understanding the life sciences, but also you're also learning the mathematical and computing skills as well. And it's the combination of those two together that really makes this unique. So I would say you need to have an interest in mathematics. And in fact, it is a requirement of the course that you have either a H5 or an O1 in mathematics to enter into the course, because it has such a kind of heavy maths component to it. So definitely you need to have an aptitude towards maths and sure. and the sciences as well.
Sure. Because, and I'll finish on this, on genetics and genomics, but it's the case, isn't it, that in biology, there's quite a bit of effort and focus being placed on generating DNA sequences in everything from medicine through to environmental science, and we need graduates to be able to analyze that and to be able to make decisions based on all of these big data, right?
Yes, absolutely. So in the last, say, 10 years or so, there's been an explosion of data available based on our DNA of any organism on the planet. So, but what's missing at the moment is actually being able, there's so much data, but we don't have people to analyze that data and to, be able to make discoveries from the data, basically. So that's what our degree is focused on, trying to generate these type of graduates for the future.
Sure, and even say to let your GP make a decision about your gut microbiome maybe in the years ahead, right?
I think it's definitely in the future, yeah.
Indeed, very good. So what I might do is move on to Niall. I see you there, Niall. How are you? Great. So Niall, you direct the physics degree, isn't that right? Could you tell us what are the options inside that degree that people can follow?
Yeah, so physics is quite a broad subject in itself and plugs into a lot of different areas. Entering into it, you kind of go into four main streams. Those four main streams cover the biomedical and applied physics. Then we also cover astrophysics, and we also cover theoretical physics. And all of those are kind of lead you into a primary IOP accredited physics degree at the end. And all of those degrees touch into different areas. So everything from climate change. And one of the things I'd like to point out specifically is Mays Head in Ireland. We're the most westerly point in Europe, so that makes us very, very strategic for atmospheric research. But also we cover areas like biomedical physics, everything from that goes into a hospital setting. So you cover anatomy, biology, and all of those areas. And then into theoretical physics and astrophysics, which you're looking at how the stars and galaxies and everything works within the environment around you.
Indeed, indeed. So we have these strengths in the university, don't we? As you say, with Mace Head and atmospheric physics, and that's one route people can take. And equally, astronomy. I think we have a long track record as well in that area with some really successful people down through the years. And as you mentioned, then medical physics, and we so happen to have Brendan Toohey with us as well, and. Brendan, I hope you can hear me and you can unmute your microphone as well. We have you as one of our guests because you're the chief physicist with Galway University Hospitals, isn't that right? Hi there, Brendan. I think you may be muted, are you? I don't hear Brendan.
Brendan would have been my original boss, actually, just to point out that as a physicist, you can actually move quite a lot into different areas. So I would have worked in a number of different areas and placements coming out of physics, and it opens a lot of different opportunities that people mightn't be aware of. As a physics degree, you can work, I worked in research and development science, in pharmaceutical, and also in biotech. I've worked as a medical physicist, so Brendan would have been my original boss in the HSE, so I would have worked as a clinical medical physicist and still do. So there's many different branches and areas that you can move out through physics. So it's one of the oldest sciences, and it's plugged into a lot of different areas. And it's kind of the fundamentals of physics are branched into all that we basically see around us in the environment. And the understanding of that is key to wanting to see how the world works. So to go and study physics in NUIG would mean that you actually can move into a lot of diversity in different areas within physics and within the environment itself.
Well, in fact, what I'm going to ask some of my colleagues who are in the wings there to do is just to make sure that Brendan and also Marion as our guests are promoted to presenters so that they are able to, in fact, unmute. So I think that may be our issue. What I want to do is I'll come back again to you, Brendan, once we have that sorted out.
No problem, Gavin. Sorry,
Gavin, I don't mean to interrupt you. That's now sorted for you.
Okay, thanks so much. Thanks very much. So Brendan, your mic should be working actually. So
yep,
could you maybe tell us a little bit about your career and how physics plays a role?
Yeah, thanks, Gavin, and thanks for the invitation. And Niall neatly introduced her there earlier, moments ago. Thanks, Niall. So maybe my own background, I suppose, is a graduate of actually UCG, and it was all UCG back in the late 80s, or early 80s, maybe in my guess, mid 80s, sorry, and graduated with a physics degree. And I suppose what motivated me, and I would always be thankful to the guy, was Professor Philip Walton. Was in physics at the time, and my 4th year there did a course in medical imaging, which is the production of medical images from X-ray and ultrasound and so on and so forth. So at that point, I always felt I was a kind of a practical type of a physicist rather than an academic, maybe. And I've seen this as a really nice practical application of physics to healthcare. So from that, then I suppose moved into the medical physics, and I'm 32 years in that area now, from a few hospitals around the country and back in Galway since the late 90s. So I'm now head of the department there, and we have a department of about 30 people, various science, engineering graduates, a lot of them from Galway. And I suppose what we do, students, I suppose, listening in or looking in, if you take your physics book, your Leaving Cert physics book, and I just looked at it myself again last night from one of my son's physics book when he was in school. You could take any chapter from that book, and it has applications in medicine. Take the gas laws.
Sure. I think perhaps
the ICU,
Brendan, yes,
anesthesia workstations. Sorry, Gavin.
Sure. Yes. So your connection isn't great, Brendan, but I think your point is really well made. That the fundamentals of physics, right, can be applied in so many areas of medicine, and I think it's very nice that people can see that. What I would suggest, for that degree and for any of the others is that it is possible to go to our course web pages and to ask a question directly, and it'll go, for example, in the case of physics, to Niall, and he'll be able to answer that. What I'm going to do is to keep moving on, and I'm going to just put to the panel a couple of questions that are coming in on the chat as well as we go along. So there's one question that I'll answer myself, and that's from Aurora, who asked whether there's any options to study abroad in European countries. And I would say yes. So it's possible to participate in Erasmus. Somebody might just type in the link there to Erasmus if they haven't already, so that Aurora and others can see it. You know, Aurora, that I mentioned some of the other options to study abroad a few moments ago. There's some questions coming in on zoology and on some other subjects. So before I move on to the rest of the panel, another thing that I would say to try to answer those questions is that the main degree that I mentioned, our GY 301 degree, which some people do indeed refer to as general science. This is the degree where you can take a pathway like zoology or microbiology, or indeed physics or chemistry or any of the other 19 that was on my slide earlier on. And I think, as Elaine mentioned, there are pros and cons to studying science through that degree, where you have access to those 19 different pathways, or taking one of our 12 others, where on day one you decide precisely what you're going to follow for 4 years, and you know in which area you'll graduate. So it's a case of whether you're the kind of person who wants to leave some doors open through to maybe second year and into third year before you know which of your subjects you're keeping and you're going to specialize in, or you want the certainty of following a set path for 4 years. All of the degrees, though, whether you do one of the 19 pathways in GY 301 or one of our other 12 degrees, result in a degree of equal value and equal depth and so on. So I think that's probably something worth bearing in mind. So I'll take just a few more questions before we come back to them again. And Nisha had asked what specialization would be best option for someone interested in climate change and sustainability. And I would offer that Niall just said that if you're interested in physics, you could also focus on climate change, and I think you could. But equally, you might be interested in something related to the ecological sciences or agriculture or the bioeconomy or microbiology. So I would suggest that many different subject areas will obviously be related somehow to climate change and sustainability. But I think probably the best one would be environmental science, because it really does focus very much on those topics. I'm going to move on just to keep up with time with one of my other colleagues here, and that's Marie Coggins. Marie, can you hear me okay?
Yes, hello, Gavin.
Hi there, Marie. So thanks also for joining us. And we happen to also be joined by one of your industrial acquaintances, and that's Marion Finnerty from Merit Medical. So Marie, you're the Program Director of the Environmental Science, Health and Safety degree. Would you maybe tell us the main points that you'd like to get across about the Environmental Health and Safety degree?
Yeah, sure, Gavin. So the Environmental Health and Safety Programme, it's a multidisciplinary programme. So students will study subjects from engineering and science, business, public policy and law, and also the health sciences. It's designed, I suppose, to meet the needs of industry today. And so we focus on the environment, the health and safety of the worker, but also quality and quality systems. It's professionally accredited, which means that your qualification is recognised not only in Ireland but abroad, and many of our students do take up employment outside of Ireland. I suppose one of the highlights of our programme, and Marion can speak to this, is that the students do a work placement, a 7-month paid work placement in 4th year. And this is organised by the University Placement Office, and students can be placed in a wide variety of organisations, from public and private sector, medical device companies, biopharma, pharmaceutical, the regulatory sector like the Health and Safety Authority, EPA, etc. And many of our students, you know, sometimes on graduation go back to these companies as employees after graduation. So that's a very, very positive, I suppose, experience for our students. The fact that they get a chance to work under the direction of an EHS professional working in industry.
Okay. So Marie, on that note, I might just ask Marion if she's still with us. Hi, Marion.
How you doing?
Hi there. So thanks so much also for joining us. So could you tell us a little bit about what the students who might come on a placement with a company like Merit Medical, what they might expect or what you look for in students generally?
Yeah, I suppose we took in our students. We take one in every year. So I was on the interview panel for them, and I was very impressed, to be honest, with the level of competency that they were bringing. We probably were too easy on the first one, and then we went fairly hard with the questions on the rest of them. But they really did have a broad knowledge, and the student we took in, we were over the moon with them. I suppose with Merit, we're a med device company, so we really do throw them in at the deep end because we're a small department. There's just me and the graduate now. So the girl we had was Kira, so we took her on as our student, and we've actually taken her back on as the graduate. So it's actually just myself and her now, because the two other people in our department have moved on. So she's been treated really as a specialist now and is doing everything that I would do. So it's quite diverse what she's been dragged into.
Indeed. And you would say, Marion, that it's a useful part of such a course to be able to get some experience with an employer?
Oh, definitely, yeah. From my own experience, I would have had my placement with Pepsi Cola in Cork, and it's worth everything. When I left college, we went straight to Australia, and it was worth everything to have something to talk about. So again, like, my parchments would have been requested from my employers in Australia, and they were impressed with the college, but they did look up the university. And if I didn't have had that to talk about, you were already at a disadvantage to try to get your foot in the door to with a company. So it's a huge part of it. I would have really struggled if I didn't have a placement coming out of it, to talk about the 5 months that you get, because you really are put to the pin of your collar. When you go to these companies, they're expecting a high level of professionalism, and you have to hit the ground running. So it's a brilliant part of the course.
Excellent. Well, thank you. I'm going to go back to the questions again, and David had asked, what exactly would I be taking part in if I decided to take up microbiology? Well, I happen to have two microbiology students here, Aisha and Keen, so you might unmute your microphones there, both of you, please. So who wants to take that? Aisha, what would you say to David? What would he be doing if he took up microbiology?
Well, I think
what kind of things in the lab do you think? Would he have many labs?
Okay, well, there is definitely a lot of labs in second and third year. They're usually about the practical.
You're in fourth year now, right? And you're doing a research project, isn't that correct?
Yeah. There usually would have been lab placement, but obviously because of current times, it has been moved online.
Yeah, so because of COVID this year, both Keen and you are doing your projects on dry topics, so you're not in the lab, but nonetheless, you would say that you're getting stuck into the topics, and what are you focusing on in your research this year?
We are focusing on bioprospecting novel organisms at landfill. So we're looking in landfill for organisms whose functions and haven't been found yet, or just haven't been.
So they might be used in industry, I guess. Yeah. And Keen, could I ask you, why did you decide to study science?
Well, I was always interested in science, but I suppose there's so much you can do. There's always so many options, whether you want to do field work or work in a lab, or if you just want to work in industry. There's so many options, and I suppose that's what drew me to it in the first place.
Excellent. I have another question here, and it's in relation to a degree in the field of maths. What are the future employment opportunities? I might ask Aisling McCluskey that question.
Hi, Gavin. Yeah, I think I've answered that in the chat already, but there's a vast array of career opportunities from an initial degree in mathematics, ranging from the obvious, research, education, banking, finance, but also going into, areas that people wouldn't normally associate with, a math specialism. Meteorology is another clear one. And I would recommend anyone who might like to explore that to drop into our web pages, because we have a lovely brochure that features several of our graduates, both recent and not so recent, and the vast array of areas they've gone into and been very successful. So it is very much a door opening subject. Indeed. And I guess you'd most likely then agree with my suggestion that it's the skills in these degrees that open the doors, and that perhaps people shouldn't 5 years prior to their career worry so much about the precise title of the job that they might get, right? Absolutely. I mean, as you say, that the grasp of logic, the problem solving attitude, the skills, the reasoning, all of it. It's so transferable. So yes, yeah, you don't get pigeonholed. Indeed. I might just go back to the student view again, just for a moment. So Shauna Burke is with us here as well, and Shauna is a physics student. Could you tell us why you chose to do physics then, briefly, Shauna?
Well, I always had quite a logical mind. I was very interested in maths in school. I would say if you're in 6th year now, if you're very interested in maths and you're good at maths and you've got an ability to work through problems, I would definitely go for something in physics. And biomedical physics specifically, I was always interested in the medical applications of physics and science. That's why I went there. Okay, so you're in that space between physics and applying it to biology then, right? I am indeed. Excellent. I will take one other question. I'm not sure if this was answered yet, but Teresa had asked whether it was possible to do first year biomedical science and then transfer into medicine. Could you take that from me, Elaine? I mean, I would say not directly or easily, right? No, that wouldn't be the norm to do that. Yeah. Mm-hmm. But it might be the case, right, that people may study for a science degree and then study medicine as a postgrad student. That is definitely a possibility, and students in biomedical science do take that option. So yeah, that's a possibility. Excellent. Okay, so we'll take maybe just a couple more questions, and then our time for the moment will be up. I'm going to maybe go to Caroline or Eilish. If there's a burning question you think I should ask the panel, would you let me know? Just verbally tell me, please.
Gavin, there's a fair bit of interest in zoology and, what you actually study as part of zoology and maybe the careers out of zoology. So maybe if somebody on the panel wants to take that, it would be very useful. Thanks, Gavin. Yeah, I mean, I can take that, and maybe Peter might hedge a bet if I go wrong somewhere because he's in the ecological sciences. But I mean, the first thing to say is that you can study zoology as one of those 19 pathways on our main degree, GY 301. So it is possible to get a B.Sc in zoology. And in that case, along the way, you'll study perhaps a little bit of chemistry and other sciences just to equip you with the fundamentals. But you'll start to focus then on zoology, and on zoology maybe of land animals, on vertebrates and invertebrates, on freshwater and marine animals. We have a really active marine science group in the university, and indeed our students get access to ship time on the Celtic Explorer and the Celtic Voyager, and we're just down the road from Oranmore where the National
Marine Institute is located. So all of these things work in the favour of somebody studying either zoology or marine science in Galway. It really will, I suppose, depend on your interests then as to which subject you might focus on in fourth year for your project. So as a zoology student, you'll discuss with your lecturers as to which project you might want to work on. So we take the approach that we try to, as much as we can, cater to students' interests so that they get to study in some depth things that they really like. Was there another question you asked me there, Caroline? Oh yes, the careers. So the careers in zoology will range from working with agencies like the Marine Institute or B.Sc or in private consultancy. Some people work with environmental consultancies. They may set up their own companies. So really, I would say that it's also a case that the skills will be transferable. We're quite up against the clock, so I think what I'm going to do then is say thanks so much to my panel. Time really flies, and I'm so sorry if you feel you didn't get a lot of airtime, but I'm sure that people benefited from hearing from you nonetheless, and I'm very grateful. I'm going to, at this point then, move on, and we will think about the next part of the evening, which is looking at sport. So for the next few minutes, I'm then going to hand it over to Ryan, who I think will be standing by. And Ryan, if you're ready, I'll allow you to share your screen if you have some slides and talk to us about sport in the university.
Perfect. Thanks, Gavin. I'll share the screen.
Great. So Ryan Guilfoyle is from Sport and Recreation at NUI Galway, and he's just about ready to go, and he'll be with you for the next few minutes now.
Can you see them slides okay, Gavin?
Yeah, we can see them perfectly.
Perfect. Okay, so thanks guys, and thanks Gavin for having me on this evening. So I'm going to just briefly talk to you a little bit about sport at the university, and particularly the sport scholarship program, as I'm sure a lot of you are interested in. To give you an overview of sport in the university, so there's 46 active sports clubs at NUI Galway presently. They range from everything from mountaineering to rowing, from rugby right to swimming, and almost anything that you can imagine is available in NUI Galway. We have 27 Olympic sports, which most of them are our core cohort of scholarship students. Within each of these clubs, which is quite unique, is we have high performance teams and we've recreational sports and recreational teams. What that means is that there's a level for everybody to compete in, and whether you're brilliant at sport or whether you're just working at it, there's something for everyone in the university. We currently have over 60 elite sport and elite scholarships in NUI Galway currently on our program. And what's worth noting, especially to all the people on the call this evening, is that you're an athlete, or you're a student first and an athlete second. And that's one thing that I want to highlight before we go on to some of the screens. So as I mentioned, what do you like at sport? Fantastic, or still working at it? To be honest, it doesn't really matter when you come to NUI Galway, unless you're applying for a sports scholarship. If you're fantastic, you'll fit right in. And if you're still working at it, you'll fit just as well in as anybody else, as we have teams that are there to cater for your needs. Now, we're moving swiftly on to sports scholarships. A lot of the benefits are of a sports scholarship. So each sport athlete will receive a financial bursary. This varies from your ability to what you need the money for and various things like that. Athletes can get financial aid for international competitions. So this is particularly applies to individual athletes such as rowers, runners in athletics and things like that. A lot of individual sports will avail of this more, as they have to self-fund a lot of their trips. And again, financial aid for international training camps. Again, this would apply to mainly your individual athletes. However, some team sports do need to self-fund some of their trips, so they can get financial aid for this. Most of the common supports would be coaching support, and what's new for the last couple of years has been well-being monitoring. So each athlete would have an app where we can monitor their well-being, how they feel daily, and we apply the medical support, performance nutrition and psychology and strength and conditioning around how the athlete is and how the student is on a day-to-day basis. Now, what's extremely important and what is a huge emphasis put on the sports scholarship program is the academic and career monitoring. So as a student in NUI Galway, as I said, you're a student first and an athlete second. If you don't pass your exams and you don't pass your modules, you cannot be on a sports scholarship program. So it's imperative that you emphasize the importance of your academic studies. The main goal is that we want to provide opportunities and resources for the student athletes that will develop strong character, academic skills, leadership skills, life skills, and career potential. And we want this to be a program that will benefit you as you go on in your future life. And then finally, all athletes will get social media training. So this is important for both your career aspects and also from a sporting point of view, so that you can portray yourself in the best possible light as we move further and further into a more digital age. Now, the types of sports scholarships, and these are answering hopefully a lot of the most common questions that will come up. There is two types of sports scholarships in NUIG. However, they're exactly the same. I know that sounds contrary, but they are the same. Both scholarships receive the same support services when in the university, and both scholarships go through the same application process. However, the only real difference to these sports scholarships is the performance point scholarship can receive 40 additional CAO points. Now, to receive these points, you must first achieve a minimum of 350 CAO points, and you must achieve the required points for your course. So I wouldn't bank on the 40 points, as it's a really highly anticipated program. So there's maybe only 5 to 6 of these on an average on a year. Both are open to current Leaving Cert students, and if you're a fifth year, we wouldn't advise applying until you're in Leaving Cert. The standard that you'd need to be at is inter-county, provincial, national or international level to apply for both. The Elite Sports Scholarship, that contains no additional CAO points, whereas the Performance Point Scholarship does include 40 additional CAO points. Again, the Elite Sports Scholarship is open to all CAO course choices. However, the Performance Point Scholarship does not apply to medicine, so GY 501, which obviously for most of you that isn't a problem tonight. And again, it's only available for full-time courses only. But what's really important to note is that both scholarships receive the same support services that was mentioned in the previous slide when in university and when on the sports scholarship program. Both scholarships, as I said, go through the exact same process. So it's the same application process, and we will then decide who is eligible for the performance points and the Elite Sports Scholarship program in the end. Now, moving on. So just to give you some timelines, as I know time is short this evening. So the applications will open on the second week of January on the NUI Galway website. You must submit your application before the 31st of March. Applications are reviewed by our high performance team within this period between end of April and early May, which interviews will then be held if you're called upon. And then scholarship offers are aimed to be issued in August and September, hopefully before CAO. So again, that's most of the information tonight. If you have any further questions, I'd ask you to pop them in the comments box and I will answer them this evening. But if you have need any questions answered past this information evening, the contact information for our entire sports unit office is here. So you have Mike Heskin, who's the Director of Sport, Fergal O'Callaghan, who's the High Performance Lead, Tanya Schaefer is the Development Officer for Clubs and Participation, mainly the recreational clubs. Ellen Kelly is our administration, and then myself in marketing and communications. We're all a small, tight-knit community, so as in we can answer all your questions should you need them, and we'll put you in the right place. Best of luck with all your studies for your Leaving Cert year, and if you have any questions, please don't hesitate to drop them into the box. So I'll pass you back over to Gavin now.
Well done, Ryan, and thanks so much. I'm sure that people found that really interesting, and I see there's some questions that you might be able to answer that are coming in about sports in the chat, so it might keep you busy for the next few minutes.
No problem. Thanks, Gavin.
Thanks again. Just before we move on to engineering, some of my colleagues tell me that there's a few last bits of housekeeping that we might do on science. So that includes answering a few additional questions, particularly about marine science and about earth and ocean science, and I'm happy to do that. I had mentioned that marine science is the only such degree in the country, and some of the good things about that degree, including our location nearby the Marine Institute and so on. But in terms of careers, again, it's the case that there will be careers in the public and the private sector in places like the Environmental Protection Agency, the Marine Institute, B.Sc, and other public agencies, as well as in consultancy, in energy exploration, and so on. And that's also the case with the Earth and Ocean Sciences degree, because we had a question about that as well. And I often get the question as to, well, what's the difference between the marine science degree and the earth and ocean science degree? And my suggestion is that the main difference is that the earth and ocean science degree includes quite a bit of physical sciences, oceanography and hydrology and sedimentology and so on, whereas the marine science degree is largely focused on the biological and ecological sciences, and there will be quite a bit of, say, marine botany or phycology, if you like, and marine zoology. So that will be the main difference. But in fairness, I think that the key skills will again be those common skills that I talked about, except that a lot of the earth and ocean science graduates tend to gravitate toward, say, careers that may be involved in exploration in the oceans, for example, in the energy sector. So I hope that helps some of you who had questions about those two degrees. So what we're going to do now is move on to the second part of the night. I'll remind people who may have just joined that you can ask questions about sport or accommodation the whole way through the evening in the chat. And there are some colleagues who can help you on that. Equally, there's somebody who can answer any questions about mature students. So with that, I'm going to move on then. And before we have our panel on engineering and computer science, we first off have two speakers. The first of those speakers is Catherine Cormacan, and Catherine is one of my colleagues who's in engineering. And Catherine, I think, has some slides on studying engineering at NUI Galway. So I'll let you take it away then, Catherine.
That's fantastic. Thank you so much, Gavin, for that lovely introduction. I'd like to just spend a few moments this evening, if you wouldn't mind, giving you a whistle-stop tour on all of the programs that we offer in the School of Engineering. But before I do, I think it's probably wise just to mention in terms of what is the difference between a scientist and an engineer. And to be fair, both of the subject choices and both of the material, there's similarities across both. But I suppose the key thing that our scientists look at, they very much focus on the fundamentals, whereas an engineer really tries to do something with that. So an engineer creates new things, applies the knowledge that we learn from our colleagues in science to create something new. So there's an element of design and make in that particular space. And I suppose you'd be delighted to know that we in the School of Engineering, we have a very long history in this domain. We've been teaching it since 1849, so that's 171 years to try to get it right. So if you were to ask then for an engineer, well, what exactly do they do? Well, engineers, they create, they build new things. Really, an engineer is what we would refer to as a creative problem solver as well too. And you'll find that the environment in which our engineers work are in very, very different spaces. We have some who work indoors, others are in outdoors, within companies, and it very much varies depending on what type of engineer you choose. There are people who work on land and at sea, and also we have some engineers who work in space. So what I'd like to do is try to demystify, I suppose, just very, very briefly, what the various different brands of engineering do and who they are. So civil engineers, they're what we refer to oftentimes as the big picture, the big infrastructures. So they look at building things like bridges, and they often work very, very closely with our friends in energy as well too. Next up, we have, what do we have next up? We have electronic and electrical engineers, and they look at systems and circuits and devices that are normally quite small, and normally looking at things like power conversions as well too. Mechanical engineers as well too they look at things that move, and they can be big or small, they can be inside the body or inside a system, they can be dealing with things like manufacturing, automation, robotics, or indeed medical devices, which leads us on to biomedical engineering, which is a large specialism of ours in the School of Engineering. And that's where we're looking at devices that you can implant into the body. And sometimes it's the mixing of medicine and mechanics as well too, as you can see from the X-ray of the hip here as well too. And last but by no means least, one of the major streams in engineering is energy systems engineering, and that has gained quite a lot of traction in recent years, where we're trying to harvest some of the energy from the natural world to create some type of power structures for us. So engineers, well, what do they do? Well, oftentimes what we do is we look at grand challenges and try to solve some of these problems. And some of these problems can be very, very diverse, ranging from energy from one side of the scheme to things like aging and health at the other. How do we design tools and devices to help our elderly people live better, more useful lives? We do a lot of information management as well too, so we're very closely aligned with our colleagues in the School of Computer Science. And also as well too, we look at a lot of things like environmental and sustainability is very, very important. So, well, you might ask yourself, is this something that you might be interested in? And I suppose some of the questions that I would advise you to consider, if that is true, is, well, are you interested in figuring out how things work? Do you enjoy, and I have enjoy in brackets there, mathematics, science, technical subjects in general? Is this what interests you the most? Are you interested in new technologies? Do you like having phones, computers, looking at or interested in the trends in medical devices and software? And are you interested in actually developing and creating new things? So we often call ourselves innovators or creative problem solvers as well too. Also, I think it's quite useful to understand that engineering jobs are plentiful, and bearing in mind what Gavin mentioned at the very outset, that the figures and statistics for science and engineering students are very, very powerful. And we are very, very delighted to let you know that most of our students get really good quality jobs very quickly upon graduation. And that's always very nice and comforting to know. In terms of entry requirements, I know this is probably being considered quite a bit, so I'm not going to spend too much time in it, but certainly for engineering, we do have to have a H5 in 2 subjects. There are your minimum entry requirements coupled with the CAO points that you're going to have for the particular year. You could also have a H7 or an ordinary 6 in 4 subjects. And of course, it must include a laboratory science subject as well too. Never fear if you don't have higher mathematics. It is possible to complete a special entrance mathematics examination, and that exam takes place kind of after the Leaving Cert is done, but before the CEO places are announced. So you do have a second chance. If something goes wrong in the Leaving Cert, or you're not happy with the particular grade that you got there, or indeed as well too, if you feel that you're a strong ordinary mathematics candidate and have decided that engineering is for you, well, you certainly have an option to do that particular exam. It's important to know as well too that we also prepare courses for you in advance to help you with that, if that's something that you're interested in doing as well too. In terms of our subjects in engineering and how we go about doing it, a lot of how we teach and what you will do if you come to join us is learning by doing. We pride ourselves in good, strong laboratory work, working with devices, working with computers, and bridging that gap between the theoretical aspects and the real world as well too. And here are some of our researchers who've developed their own car, an ecological friendly car, and it was like the Formula One for motor racing, for eco-friendly cars, and our team has done extremely well in that space. Just to let you know that our driver on that team as well too is powered by a female engineer, so there are many, many opportunities too. and we're encouraging a lot more females into the area than possibly would have happened in the past. Very briefly, in terms of structure, all of the people who do the 7 core engineering courses follow a common first year. Our project and construction management course is slightly separate. It's a B.Sc, so it's a Bachelor of Science rather than a B.E, a Bachelor of Engineering. And people then specialise for second year, third year and fourth year courses. There's a work placement for after that, and then of course you have a 5th year now, so we're integrating moving from a 4-year cycle to a 5-year cycle. And I suppose it's one of the key things that I would strongly recommend for people who have a specific denomination in mind. So for example, if you decide that you wanted to do either biomedical engineering or mechanical engineering, I would probably advise that you choose that from the outset. While a lot of people will do the undenominated degree in the first year, we have to clarify and specify that if you don't have the chosen points initially for the specialism that you want in your CAO, that it will not be possible for you to get into that degree. So that's just important to bear in mind. Project and Construction Management is a Bachelor of Science, and again, it's a 4-year program. And it is, while it shares some subjects with some of our engineering degrees, it's pretty much a specialised and denominated program on its own. All of our students will have work placements, and that's a really, really nice facility to gain skills in the workplace so you can apply your knowledge and of course equip yourselves with some issues that you might have to have and build connections and networks so that you can do final year projects as well too, and hopefully move on to get a placement or a full-time position later on. We have wonderful people, and some of them here today, who have helped us in the past and continue to take our students as well too and equip them with great quality skills. So we're very, very thankful to our industry people because they help to scaffold us to educate, of course, our engineers of the future. And of course, our best advocates are our own engineering graduates who have wonderful connections with us, their alma mater, and continue to work with us as well to upskill as well to the new people that come with them. We're very, very proud of our new building. We have a state-of-the-art building, and we can definitely say it's the biggest and hopefully the best engineering building in the country. And it's a wonderful one-stop shop for everything that you will need when we finally get back into working life and to get in there full-time. My name is Catherine Cormacan, and if you have any questions either today or even later on, please feel free to contact me at any time, and we're very, very happy to do what we can to answer some of the questions that you may have.
Excellent. Thanks so much, Catherine. That was really good. Without any break, I'm going to go straight on to Des, and that's Dr. Des Chambers, who is a colleague in computer science. So Des, whenever you're ready, I'll let you share your screen, and you have some slides on computer science and IT.
Okay, hello everyone. Let me just share screen here.
And when Des is finished, then we'll be moving on to the panel discussion at that point.
Yep, 1 second. I have 2 screens in front of me, so I want to make sure I've shared the right one. So my first IT challenge of today. Okay.
Well,
here we go.
Yes, indeed.
Okay.
We can see you. Yes, great.
Okay, that's great. Go from the start then. Okay, can you see that?
We can.
Oh, you see the preview as well, is it? I have the wrong screen, I think. Hold on a second. This is the problem with 2 screens. My sincere apologies. I'm not doing a great job on this. So.
I'm tempted to say that this is just the irony portion of the evening where it happens on computer science.
Okay, let's share the other screen. Sorry, it's just I have 2 screens open and I've actually shared the other one. So let me go again.
Just while Des is doing that, I'm going to take the time to just ask Catherine one last question while she's online there. So Dara has asked, and I think you might have answered this, are there any restrictions for specialising after first year in undenominated engineering? So Catherine, if you don't mind just answering that before Des goes. You're muted, yeah.
Sorry, thank you. the only restrictions is that if the student chooses to take undenominated degree and gets the points for undenominated engineering and chooses to move into a specialism where the points are higher for that specialism that they have not achieved in their leaving cert, unfortunately, they can no longer choose that option.
Sure.
So that is a
would
restriction.
Be yeah.
Yeah. Invariably as well too, you know, the college or the School of Engineering tries very, very hard to accommodate all students who choose a particular avenue, and we will do what we can. But unfortunately, our hands are tied in this instance, because if they don't have the CEO points for the particular discipline, it's not possible to enter that. So therefore, we would advise that if you have a passion for one particular area, it's possibly best to choose that from the outset.
Indeed, just to be safe and I suppose, you know, the advice generally, given that this is a CAO information evening, is that, you know, you should be thoughtful as to how you approach your CAO application, and certainly try to apply for what you think will be your favorite subjects, rather than the ones you think you're most likely to just achieve. Yeah, so
choose what you love first. It's most important.
Absolutely.
Okay.
So thanks, Catherine, and over to you then, Des.
Can you see my screen?
We can indeed.
Okay, hello everyone. So my name is Des Chambers. I'm the Program Director for GY350, which is the B.Sc in Computer Science and IT. So actually, Catherine's talk just now was, I'm probably going to say a lot of the same things, because there's a fair bit of crossover between computer science and engineers, and many computer science graduates end up with a job title like software engineer. So we've, until recently, we were actually part of the same School of Engineering and Informatics. So there's a good bit of crossover there. So I'm going to talk about computer science and IT. The building on the right is where I work, and this is the School of Computer Science. So it's if you're driving across the Corrib and look into the left at the university, it's one of those new buildings at the back there. It's quite visible from the Quincentennial Bridge as you're going over. So what's computer science and IT about anyway? Well, I suppose the best thing I could say is that this, what we're doing right now wouldn't be possible without it. So computer science has been, without computers and computer scientists, we wouldn't have platforms like Microsoft Teams. We wouldn't have the internet itself. We wouldn't have the network that actually allows us to have this conversation across the internet this evening. So, but fundamentally, computer science is the study of computers and our relationship with them. So it spans a lot of things, but some of it can be theoretical. So you have people who work in theoretical areas of computer science, like algorithms and things like that, and developing new ways to do artificial intelligence and all this type of stuff. But a lot of it is quite practical as well, and many graduates of computer science courses end up working professionally as software engineers, where they do, you know, jobs that involve software design and development. They design the apps and the operating systems. You know, when you boot up your computer, how does it actually get to load anything? You know, so somebody had to write the software to make that work as an operating system. Somebody wrote the apps on your phone. Somebody actually wrote the firmware that allows the router, your Wi-Fi router, to actually work. You know, the fact that you can actually connect to the network at all is all down to software systems. Somebody had to design the network protocols and implement driver software that can actually transport your data across the network. So it covers a large number of areas. Some of these you'd be familiar with anyway, but a lot of areas nowadays are more specialized, like machine learning and artificial intelligence, and we're seeing more and more advanced uses of these things across lots of different industry domains. So a lot of this stuff you're well aware of anyway. If you go into any, I'll show you just a brief example. Obviously in medicine, they're used, devices are more complex now, they're software driven. You know, everything from the chart at the end of the bed has become automated and is essentially now just a data entry system to actually record that information. Home entertainment. Can you imagine a world without Netflix at this stage? You know, to think with most, well, certainly at my age, I grew up in an area, we started out with one television channel. I'm just about old enough to remember that. And we now take it for granted that we have TV on demand. Even the concept of watching the news at a particular time is something that's definitely a generational thing, I think, at this stage. So And there's no going back, but what made all this possible, you know, on-demand TV is a result of advances made by software engineers and network engineers. It's as simple as that. It's home automation and security, all your favorite little gadgets and apps that we use around our houses. Some of us like to have long conversations with Alexa, but Alexa is basically an artificial intelligence. And she's only going to get smarter as time goes on. With the, you know, that could be a scary prospect, but it's going to happen. We take it for granted now. We can control aspects in our environment off our phone. You know, we can monitor buildings, we can monitor security systems, set the heating, set our schedules, and you know, basically have all these great apps to help make our lives that bit easier. You know, certainly what has happened in, I think 2020 has brought it into sharp focus that we can actually work remotely. You know, this really wouldn't have been possible even 10 years ago, I think, to do what we're managing to do this year at this point in time. So Catherine talked about smart energy and other things. So there's lots of, you know, very impressive new types of applications out there. I recently got a new car that has an app with it. It's actually an electric car, which I'm delighted with. I'd have to say that another great innovation, but the app actually can control many aspects of the car itself and give you information about it, like, you know, the battery charge, lock the doors, turn on the lights, locate the vehicle if you wanted to. And all this stuff is running off your phone, and it depends on very complex software systems that can, you know, that depend ultimately on very powerful and widespread networking, you know, availability as well in our environment. So computer scientists work across all these types of areas. We know that computers and software and the internet are critical to all areas of modern society. And, you know, we find graduates that come off these courses, computer science courses, they often end up initially, at least, as graduates with job titles like software engineer or software developer. They're employed in virtually every industry sector. People often think they only work in the big tech companies, but they actually work everywhere. You find them in virtually every industry vertical, because all these industries use and are using and will use more and more computing systems to automate and make their businesses more efficient. So across everything you can probably imagine. So surveys done every year. We've been keeping an eye on these for a few years. So basically software developer or software engineer, whatever you want to call the title, they're usually in the top 3. And now this is data from the US, but it's a good representative data. And these jobs basically are, it's usually rated, in the last 5 years, it's probably been #1 for about 3 out of the last 5 years. And the reason it's so popular and rated as one of the best jobs out there is because you are needed in virtually every industry sector, and people are well paid, they have good job conditions. The potential salaries in some of these companies is higher than people would expect. The starting pay, just to give you an idea, for software engineers or graduates, typically in the low 30s, but they actually progress very quickly. And it's not unusual in big tech companies to find principal engineers paid well over, you know, 100,000 a year with benefits, sometimes with share options and so on. So what tends to happen is the pay tends to go up quite quickly early on in the career as people actually get experience and actually, you know, their skills become very much in demand at this point in time. So is there demand out there? There certainly is. I was reading I think it was last weekend in the Irish Times, there was an article about, you know, jobs and careers in Ireland, and the point they made is that if every single CAO applicant this year applied to do computer science, it would not fill the jobs available. That's everybody doing the Leaving Cert next year. If every one of them chose computer science, we would still have jobs left unfilled in this space. It is, you know, because the demand far outstrips the supply at this point in time. So the B.Sc in Computer Science and IT, it's a core computer science software engineering degree program. It's very much like the engineering programs Catherine spoke about. It's a 4 years honours degree with a work placement. Its emphasis is on teamwork and projects, and you learn how to program by actually doing it. It's not, you know, some of these subjects, while there's theory, in many cases, you really just learn it by actually using it and doing it and you know, break it and fix it again. And that's how you learn a lot of this stuff in reality. This is a very quick snapshot. I'm not going to talk through this slide, but this is the various years of the program. So all the kind of subjects you'd expect, from foundational subjects right through to a lot of programming, a lot of software engineering, a lot of advanced computer science type subjects like artificial intelligence, machine learning, and right through to internet technologies and data management with the final year project. So again, the structure around placement is similar to engineering programs, 8-month professional placement. Almost all our students, I think about 95% of the students in the last few years have got professional placements in third year. And in fact, those who don't, usually there's a reason for that. It's not that the demand isn't there, because possibly for family reasons or whatever, they can't actually do it. So GY 350 graduates, as I said, they work in virtually every industry sector. I could have filled 2 or 3 slides with logos here, but you know, all the big tech companies, Facebook, Amazon, Netflix, Google, they have big operations in Ireland. People don't realize the biggest cloud provider in the world is Amazon, actually, Amazon Web Services. They're massively huge in cloud computing. Half their engineering team is in Dublin. The other half is in Seattle. And that's not unusual. Ireland, we punch way above our weight in terms of the amount of tech that actually is located here, tech companies. All the big internet companies have very, very large operations in Ireland with huge data centers. They employ a massive number of people here, and we just can't fill demand for that. So there's a huge opportunity. So this is for you if you have an interest. It's like what Catherine said, it's very similar to engineering programs. If you have an interest in problem solving, creating new things, research, if you have an interest in technology, it helps. If you have an interest in, you know, basically working in this type of space, then it may be for you. You do need a good standard of maths. I realize now I don't have a slide on entry requirements, but the maths, you don't need honors maths, but you do need an O2 and lower level maths. That's the cutoff point. So there is a maths entry standard, but it's not quite as high as the engineering degree programs. Just last slide, other computer science pathways at NUI Galway. So I've spoken about GY 350, which is the main kind of 4-year degree program that doesn't focus on anything else, but computer science is available as a pathway in the general science degree, GY 301, as a computer science stream. The arts degrees, the GY 101 is the undenominated arts. You can actually take, it's called IT, but it's actually computer science subject. And there are a couple of new programs in arts as well, denominated programs. The last one there might be interesting. There's now a computer science subject at second level, and that degree program, the BA in education, it's a BA in computer science and math studies, and it's basically for people who want to become secondary teachers and teach maths and computer science. So there are other pathways there, and we do also take transfers of students from undenominated engineering into second year. So if you're not sure what you want to do, undenominated engineering can be a good option, and then you can decide, do you want to go to, you know, become a civil engineer or go to biomedical, and we do, some of them come to computer science at that stage. So I'm going to pass back to Gavin at this point. Hopefully that didn't go on too long, and I'll see, can I stop screen sharing now? So.
Excellent. Thanks so much for that, Des. And I think I'll probably be able to take control of this. And yes, so you'll see my slide there, I guess. And what we'll do now is we'll move without any delay on to the panel discussion. So let me introduce the panel to you then. So Catherine and Des are staying with us. And I'm really happy to say then that we also have the following joining us. We have Martin Glavin, who in fact is Professor Martin Glavin from Electrical Electronic Engineering. We have one of our current postgrad students and a former graduate of the Biomedical Engineering degree, Aveen Sheedy. And Aveen, amongst other things, might be able to talk to us about the new society she has set up. So we'll have a word with her about that. And I'm especially happy to be able to welcome Anya Brazil, who was the vice chairman at Thornton Tomasetti, an engineering firm in New York. Anya is a graduate of University College Galway, and therefore of NUI Galway and is a structural engineer, and was in fact recently awarded with an honorary doctorate by the university. So she's one of the graduates of which we're very proud. So I might actually go there straight away and say hello to you, Anya, and welcome you to us here this evening.
Thanks, Gavin.
So,
can you hear me?
I can hear you very
Good.
well. How are you doing?
Good.
Excellent. So what I want to do is, well, talk to you about a few things. But firstly, could you tell me, you studied at UCG, and what did you study exactly, Anya?
Yeah, I studied civil engineering, and I graduated in 1977. There weren't a lot of choices of engineering back then. It was civil, and halfway through my years, I think we offered industrial as well. So that was the only choices of engineering, but actually it suited me very well because I knew I was interested in building design, and that's sort of a little bit even more so than the bridges and the hydrology and the flood control, water, environmental, all the other aspects of civil engineering that were available back then. I kind of had that. I just knew I was interested in buildings a little bit, and luckily, where the courses were there to focus on that in your third and final year back then, and then from there I ended up getting into the building design aspects of our.
And could I ask you, as a young girl starting off in engineering, was that unusual?
Well, that year we were 3 out of 60, so 5% of the class were women. We had a great time. I tell you, we really enjoyed ourselves and had a good time, and were very well respected by everybody in the class. So we found it to be very good camaraderie and everything else. So there was no problem being a woman in engineering in college. And when I left and it started to work, it was the same very low percentages of women, especially at that point in senior ranks. I mean, there were none, really. All of my bosses at every single level, all of my mentors, they were all men. When I eventually, I worked in London for a few years and back in Dublin, and then I went to New York and started work with the firm that I actually stayed with for my whole life after that. I was 38 years with them. But when I started with them, we were about 50 people, and there was one woman more senior than I was, who was, probably, I would say I looked up to her, and she certainly taught me a lot. And then my career took off after that, luckily, and I got just exposed to so many different kinds of design, design of high-rise buildings, design of hospitals, and sports arenas with long span roofs, all kinds of things, really very exciting. One thing about engineering and in general, I think almost all the engineering disciplines, you work in teams. As you said, you're solving problems. Catherine, I think you said solving a problem is the issue, but you don't do it alone. You do it in teams, and that teamwork really can be just so rewarding. It's great fun, and you realize, that you have a strength and you have weaknesses, because everybody does. But within the team, if you have a team together, you all complement each other, and somehow by having that conversation and working through the challenges, you can come up with the right solutions.
Sure, absolutely. And just to finish on, I guess, on the first topic, then, I think we're at something like about 20% of the engineering students are female now, so we're certainly improving, and I think Galway's really doing quite well, and is very purposeful about making improvements in that way.
I think it's.
But could.
Yeah. Go on.
Yes. Well, I guess I was going to ask then, did you see that the landscape in engineering was changing then throughout your career for women?
It's certainly, I had no barriers, really. There was the obvious thing at the beginning when you know, whether it is you go to a site or you go into a meeting and you're the only woman in the room, there you do have to prove yourself. But young men had to prove themselves too, but it might have been just a little bit more difficult. But the landscape has started to change, but it's a little bit disappointing that it's taken so long. If you had asked me back then how long I thought it might take, because I taught, you know, as adjunct professor in several different colleges in the US, you know, at Cornell and at Princeton. And when I was teaching those classes, there would be, at that time, 33, maybe 35% women. And as we hired women in our industry, we were hiring a lot of young women, but still the ranks of the senior women are thinner than they should be, I believe. So there's a constant battle to try and get women to stay in this career. It's so rewarding and really so much fun as well as a challenge that I'm surprised that we haven't attracted more and more women over the years. But I love seeing young women coming into our industry. And as a result, a few years ago, I actually started the Maura Brazel scholarship named after my mother in NUI Galway, because my mother worked for almost 40 years in the bursar's office. And, you know, so she knew the college, you know, very well, but she hadn't even got a leaving cert because she didn't have the opportunities, but I got the opportunities. So NUI Galway gave me, you know, really great background and a very, very solid base to start with. I did then have to go on and do a master's in London. Didn't have to, but I felt I needed it. But now with the 5-year course, I think that solves a lot of that, you know, you really can't learn enough, I think, sometimes in the 4-year course. So I love to see the 5-year course.
Indeed, absolutely. And could you perhaps just tell us a little bit about that scholarship, the Maura Brazel scholarship? So it is for civil engineering students, isn't that right?
It's for civil engineering students, for women who want to study civil engineering. Essentially, it is awarded at the end of the first year for 3 years, 3 consecutive years, €2,000 per year. And you just have to maintain an honours level. I believe that's the standard that's been set, so that you have to maintain some level to be able to continue to get it. And it doesn't, you know, I don't think you lose other opportunities to get funding in different places, but, you know, it's like a prize, I guess they call it, or scholarship. I'm not sure of the total terminology in the scholarship department over there, but I do know that, you know, it's the idea for me was that I felt I wanted more young women to just have maybe a little bit of an extra chance to study civil engineering, because I know that I used to find it very hard to hire good women into our company, and I think that, you know, now I look around and I watch the young women that I've left behind, and I think it's fantastic to see people doing what I was doing before.
So I'll get a chance to come back to you again, Anya. I might just move over to Martin, because he's beside you on my screen here. Martin, I see that you've been busy answering lots of different questions there, mostly around people moving from the undenominated course and so on. Is there anything you want to say on that, maybe to kind of sum up some of the answers you've been giving?
Yeah, I think a lot of people are just worried that if they go into undenominated, that they're going to find themselves in a course that maybe they don't necessarily want. And we really do take a lot of steps to ensure that situation doesn't arise. Up to now, we have, I suppose, had a lot of flexibility in allowing students to take whatever they wanted. They could come in and do their undenominated first year, and then pretty much go into any program of their choice. But it's not really by choice we're doing this. It's the rules have I suppose been tightened on us somewhat, in that, let's say you come into a program come into undenominated with 480 points. It's kind of the example that I used there on the chat. And let's say you want to do a program that is sitting at 500 points. So you're 20 points short of that program. When you go to second year, you can't go to that program now. You must choose a program that is of the same points or lower. So I suppose Catherine's point really at the outset was, if you like a program and you think that's the one for you, choose it straight away. I suppose the other way of leaving the options wide open to you is get as many points as you can. And then all of the programs are open to you. So you do get your first choice that way. So they're probably the two strongest ways of getting what you want. But we will certainly work with any student and try to help them through
Sure.
to make sure that they get a choice that is suitable for them. You know, there's no bad choices here.
Indeed.
All the programs are very rewarding, and all of them will lead to a very fruitful career. And it might just require maybe a little bit of thinking, a bit of understanding. And that's the great thing about undenominated engineering. It gives you a chance to, I suppose, take a little bit more time to understand what's in all the different types of engineering. I think students sometimes go into certain types of engineering thinking that it's one thing, only to find out that maybe it's not what they expected, and that maybe there's something else. We see that a lot with electronics. People think it's just about kind of gluing little components together, and then they find that they're working with robots and drones and 5G communications and all that kind of stuff. And lots of people maybe haven't had a chance to program in the early years, properly program, and they find, gee, it's not that kind of mystifying thing that maybe they had some minor experiences with in school, that there's actually something really challenging and something rewarding, and that there's something inside of them that kind of helps them to understand and solve those problems. So I suppose giving people a chance to experience a little bit of a broader kind of a scope of the different types of engineering is a really useful thing.
And you might answer a question for me, and maybe it's in the heads of some of the prospective students who are chatting here. And well, I've got a couple of questions, but one is, what is the difference between electrical and electronic and computing engineering?
So they're two sister programs. There aren't that many differences. So electronic and computer engineering, they spend about 20 to 25% of their time taking the computer science courses. So we see electronic and computer engineering as kind of the marriage between hardware and software. So electronic and computer engineers kind of focus on a lot of software and also computer design. Electrical and electronic engineers, a little bit less software and more on power and energy. So we kind of say that the electronic and computer people move data, the electrical electronic people, they move energy. And kind of think of it in those terms. It kind of keeps it simple, I think.
Okay, so I'll get a chance to, I hope, to come back to you again, Martin.
Sure.
If Aveen is there, I might be able to have a word with her.
Hi, Gavin.
Hi there.
How's it going?
I'm great. So very nice to see you, and thanks for joining us.
No problem.
So let me introduce you. So Aveen, as I had said earlier, is a current PhD student and is, if I'm not mistaken, a graduate of the biomedical engineering degree.
Yeah, correct.
So maybe let's start off on your undergrad first.
Yeah,
Aveen.
no problem.
Why did you choose?
I chose engineering actually as a result of taking, I think, like a 2 or 3 day summer course in NUIG in the engineering department. It had been put to my attention by my engineering teacher. I was lucky enough to do engineering as a Leaving Cert subject in 5th year, like between 5th year and Leaving Cert. And we were given the opportunity to come in for about 2 or 3 days, have a look around, do a few experiments, obviously completely mentored and whatnot. And I suppose just given a very brief taster in like what civil was and what electronical was, and a tour of the building, and just completely fell in love with it. Like, the building is absolutely spectacular. So that was me set on what I wanted to do. I was very lucky going into my final or like Leaving Cert year knowing exactly what I wanted to do. What I thought was exactly what I wanted to do. I was hell-bent on doing energy systems engineering. I just thought windmills and hydroelectronic or electricity was like the best thing ever. And it's great. But I suppose I went in as an undenominated engineer and was going through all the different fundamentals. So it's like a course where you do, say, 3 weeks of mechanical, 3 weeks of civil, etc., the whole way through. And kind of plodding along, got to to energy systems, and like really didn't like it. And I started to panic at this point because I was going, oh my God, like this is what I wanted to do. I don't know, like hadn't really thought of anything else, nothing else. It kind of tickled my fancy. And then luckily biomed was the last, I think, 4-week module. And I loved it. I absolutely loved it. We had a lecture with Garo Jalir on bioelectronics, and I was like, oh wow, this is great. Really just like took my interest, and I was kind of going, okay, this isn't something I had thought about before. And then Professor Leisha McNamara had taken us for the following, I think, two or 3 weeks, and brought us through like biomechanics and different biomaterials, and I was like, oh my God, this is like just absolutely amazing. So that was me. I was kind of going, hallelujah, I'm not going to drop out of college. So yeah,
okay,
I
so
chose.
The penny dropped, right?
yeah, completely. It was like light bulb moment. So yeah, got through first year, got through second year as biomed engineer. Got through third year, and then back in my day we had like a 4-year degree, so you do your first like 3.5 years, you go on placement in second semester of third year for 9 months, and then come back and do your final year. I know that's a bit different at the moment, which is completely fantastic. So I was lucky enough, I was given the opportunity to study in America for the second semester. Well, more work than study in a cancer cell research lab and a 3D printing lab in a university called Lehigh, and loved it. I thought, okay, lab work, yeah, that's exactly what I wanted to do. I wasn't really sure about industry because just personally it didn't, tickle my fancy again, but I got into this lab and I was like, wow, like almost another light bulb moment of going, yes, okay, solidified my reasoning behind choosing biomed. I came home then into my final year and did a really cool project with based on the heart, and loved it. It was a tissue engineering project, so it is not something that's, I suppose, there's a lot of in NUIG. It's more focus on FEA, but there is little bits, there's more of it trickling in now, which is so great to see. And graduated. The opportunities I've been awarded due to being a biomedical engineer graduate from NUIG is just like world class. I went to UCC to do a master's then in biotechnology, and through that I was able to go to MIT for 7 months. And like that was the reason I got to MIT, was because I was a graduate of NUIG. Like the connections that I was able to make during my undergrad completely saw me through. Came back then, worked as an R&D engineer, so that's research and design or research and development. So you're at the very start of a device's lifespan, and you're kind of figuring out what's going on with it. So I was working on a device in a startup in Merview, so not too far from home, and came into do a PhD then. So yeah.
Indeed. And briefly then, what is your PhD focused on?
So briefly,
it's a bit ahead of most people, right, to think about their PhDs.
So yeah,
oh God,
yeah. My PhD is on developing immunotherapy. So they're drugs that use your immune system to treat ovarian cancer. So we're just looking at a few different immune cells that you can you'd have within your body itself, and kind of altering them to then be put back into the body to kill cancer, essentially. So yeah, super cool project, working with an amazing supervisor. So yeah, loving it. I'm so happy to be back.
Just before we finish, you might just briefly tell us about the new society that you have set up in the university then, Aoibhinn.
Absolutely. So this society is my baby. I love it. It's called YSTEM, so it's Women in STEM subjects, so science, technology, engineering and maths. Figures were thrown around earlier, but I've looked at this recently for a grant proposal that I'm writing, and it's 25% of all graduates at the moment are women, and that ranges from about 20% in, say, technology, so computer science, and goes up to about 30% in like biology and the kind of more bio areas of it. Of engineering. Of engineering. So we're very underrepresented within the workforce. So I founded this society this year to kind of give women studying STEM subjects within NUIG a place to kind of come together and talk about maybe the struggles they're having, or like get advice from previous students. We're looking at connecting with industries to provide mentorship. I'm actually working with Gavin at the moment to develop an internship program for courses that don't have one built in. So that will hopefully be up and running in a pilot term this coming summer. So it'll be open from first years to final years. And yeah, just providing talks. So we've had 2 speakers, a lady from HP cybersecurity, and then one of our lecturers from biomedical engineering. So they're the 2 we've had so far. Yeah.
So you and I do have great plans to take over the world, all right? So
world domination, NUIG domination.
Indeed. Des, I might briefly just put a question to you. Rowan has just asked, why should he choose computer science here at NUI Galway over computer science at UCD or Trinity? So there's an easy question.
I think I just answered it in the chat, but
okay.
I mean, basically, they're all good courses. I would say pick your geography actually on that one, because if you prefer to be in Dublin or Galway, I would point out that NUIG and Trinity are the only 2 in Ireland actually accredited by Engineers Ireland computer science degrees, and that's which is good, because it means that they've been externally validated and professionally validated. So I would say we're confidently say we're at least as good as any of those. I don't want to talk them down, but there you go.
Well, indeed, yeah, indeed. Absolutely, and I think it kind of relates to the point I had earlier on that all such universities will have the same or a similar level of excellence. It's just what we think we might be able to do exceptionally well here. But I think the accreditation thing is really important, isn't it? And equally, it's something that is a really strong feature of the engineering degrees. Martin, you might just briefly speak to accreditation, if you don't mind.
Okay, yeah. So as you said, accreditation is hugely important. I suppose students might be wondering, well, what does that mean to me? Well, if you're going on an accredited program, the first thing is it's a measure of quality, because that an accredited program has been very, very carefully and very thoroughly vetted by an external panel, by people from around Ireland. Indeed, our courses have even been vetted by people from across Europe to ensure that they stand on a world stage. So the first thing is you know that the qualification that you receive has I suppose received that quality seal of accreditation. It also offers you mobility, because there are international agreements between many countries. So the likes of the US and Canada and Australia and most of the countries in Europe, a lot of other countries around the world, South America, Africa, all those places, they're all signed up to an agreement that means that if you have an accredited engineer in Ireland and an accredited engineer in America, that when we go over with our qualifications, they're recognized over there in the same way as we recognize their qualifications coming to us. So that mobility is a huge opportunity for engineers to take their skills and work with them around the globe. So I suppose they're the 2 main things. There's been, I suppose, some discussion even in the chat about the 5-year programs and the fact that we've gone to a 5-year program. So really, this has been something that has been developing over a number of years, and that in order to receive the chartered engineer, or to meet the educational requirements for chartered engineer, you need to have 5 years of learning done. So you need to have done 300 credits. So we've a few years ago, we introduced this extra year onto the engineering programs. So you could always do a master's, but I suppose we've more tightly integrated it into the programs. So now that when you go through the full 5 years of engineering, you have, I suppose, 2 degrees. You have both a BE and an ME, but you also now meet the educational requirements for chartered engineer status. You can still leave after 4 years. You can still get chartered engineer after 4 years, but it means that you have to take some additional courses, or you have to get a little bit more experience before you can get that full chartered engineer status. So the students are only just kind of learning about accreditation or learning about the 5-year program now, and they're only hearing about it, but it's actually been quite well established over the last few years.
Okay, so I think that's important to say. One, because it was a common question in the chat here, and equally, as you say, to make it clear to prospective students that this isn't something we're just dabbling in. It's something that's well established, and you can see the importance of both accreditation and having the integrated BE and ME.
And it's not just at NUI Galway, it's every single engineering school in Ireland has to do the same thing. That you know, you can get a level 8 from any of the Dublin universities or Cork or Limerick or anywhere else, and they still have to abide by the same rules. So you still need the 300 credits. You still need to do the 5 years in order to meet the educational requirements. So it's not that we hand you a chartered engineer crown at the end of that. You still have to prove yourself in the work environment and all of that, but at least you do meet the educational requirements. And the other thing that it does is, what we're seeing more and more is that people are coming in from abroad with master's degrees, and they're sitting in the interview rooms beside people who are graduating from the Irish universities. And more we're seeing that the people who graduate from the Irish universities are coming across the people who are coming in with the masters. It's becoming the norm across Europe. So it kind of is becoming the norm now here. And we're just at that point where we're kind of making that I suppose, that psychological change in our mind, that it's not just a 4-year thing now in engineering, it's moved on to a 5-year thing. And I think that really is starting to take effect, and that is really starting to become kind of accepted now across the continent.
Okay, so we have 3 minutes left then in our session, so time really does fly. I'm going to pick up on one question which may have been answered completely already, but Harry had asked also about environmental engineering and whether it was a component of the civil engineering degree. I think Catherine did answer that it is indeed, yes. And I would give the example that my own work as a microbiologist involves collaborating with civil engineers on campus on environmental engineering problems. So it absolutely is a focus, and probably an increasing focus, of civil engineering, and I think is an example of where biology meets engineering in another place, just as it does with Avine's work in biomedical engineering. I think what I might do is ask Catherine one last question, and then I'll wrap up by asking my colleagues if we've missed something in the chat. So Catherine, you might just tell us, just in case anyone has missed it already, about CAME.
About CAME, well, actually, I think Martin's probably better equipped to help us with this. Maybe Martin, would you mind taking this question? So because
just in 30 seconds, Martin. Yeah.
Oh. Yeah. So CAME is a program that was initiated a few years ago, where second years will mentor. They'll take the first years in groups and mentor them. So it's a program that they're trained on. So you're not just let loose on second years who have no training. So they will support you. And really, it was mentioned in the chat. It's about making that transition from the school mindset to the university mindset, and just to develop your skills, develop your ways of thinking, and how to attack the problems that are put before you, and how to work in teams, which is something that maybe you're not as used to in school as you might otherwise, or we might want you to be. So it's a very well defined, well run, carefully managed process. Where people can ask questions of their peers. It's easier to talk to another student maybe than it is to talk to a staff member.
Indeed, and as you say, perhaps helps with this transition from school to university as well. So just before I perhaps get a final word from Anya, so I'd like to do that. Could I ask my colleagues who are monitoring the chat, is there anything else that you think we should address in the last minute? Caroline or Eilish?
Maybe, there was a question that came in there about aeronautical engineering. So obviously we don't offer it at NUI Galway, but would there be a course that you'd recommend if a student was interested in aeronautical and wanted to stay at NUI Galway?
Probably mechanical engineering is the nearest one, because they would do a lot of kind of modeling and fluid dynamics and that kind of thing. So the likes of, take the Geek project, there's a lot of work done on designing the airflows around that vehicle to make sure that it slips through the air. So it's a very similar design mindset to somebody who would be doing aeronautical engineering. So they have to kind of run models and simulations and look at the drag and look at the forces that are on the various materials and the various surfaces of the vehicle. So the mechanical engineers would be the nearest to that.
Mm-hmm. Excellent. I think that's really good advice. And for anyone wondering what the GEEK is, it's the Galway, is it energy efficient car, I think.
Car, yeah. And actually the GEEK team just today were #1 in the world on one of the challenges, where they for sustainable transport of goods. So there's we can't actually run the car this year, but sub teams actually went and competed on a number of challenges set by Shell. So we're very, very proud, and I actually haven't heard how they did today, but they were actually #1 in the world. It was nice to see.
I'm sure people will probably find it on Instagram or something anyway. So I'm sure it's all over social media all of the time. So thanks for that. And what I would like, as I said, to do is just to finish with Anya then. Anya, maybe the best question at this point would be, generally, what advice would you have for the guys and girls who are on the chat and listening to us this evening and they're thinking about maybe doing engineering?
Yeah, if you have any interest in this problem solving aspect, you'll find which direction you want to go in engineering. But you really, I think you need to have a love for it. Engineering is something that you love to do. You are challenged by it. People come to you with their problems and you help solve them. And all the years I worked, was what I really got a kick out of. And probably the one thing I miss now that I'm just slipping away from full-time working. So solving the problems for people. And if you have a good math background, I had no idea what engineering was, really. I didn't. And there was no non-denominational. It was just, all that was really available to me was civil. So I kind of fell in, very, very lucky to fall into it. But people now, I think, have more opportunities to figure out what they really want to do.
Excellent. Well, I think that's very sound advice. So if you want to get into the problem-solving business, then engineering could be for you. And I'll still have a shout out for science if there's still anybody listening for science. I think if you love it, go for it. And some of the questions that have been coming in have been asking about, do I need to do much physics? And they seem afraid of certain subjects in first year. And really, I would say, look, you will get beyond first year. There'll be lots of support. You don't need to worry about subjects that you haven't previously taken. You'll be okay in first year. And the bottom line, really, I suppose, is to follow the subjects you think you'll really love and that you'll enjoy doing, because that's the best way to get good grades, I think. Okay, so with that then, I'd like to thank all of my academic colleagues. I'll see you again, and I'll hopefully in person get to buy you a coffee in lieu of this evening. But in particular then, I'd like to thank our 3 special guests: Brendan Toohey, the Chief Physicist with the HSC and Galway University Hospitals; Marion Finnerty, the Senior Environmental Health and Safety Specialist with Merit Medical; and last but certainly not least then, Anya Basil, the former Vice Chair of Thornton Tomasetti, for giving up her evening and giving us some really great advice to everybody listening. So with that, I think I'll call it an evening. I'll thank all of the audience. We had a really great turnout for coming and spending your Thursday evening with us. I hope it was of some use, and goodbye again, and thanks very much.
All right. Thanks, guys.
Bye.
Bye.
Bye.